Howdy, everybody. I hope you're having an absolutely lovely day. I know I am, and it's only going to get better in just a few minutes here. My name is Tim Sylvia. I'm an editor with PV Magazine USA, and I'll be one of your co-moderators for today's webinar about large format modules and how to increase, extreme weather resistance with large format modules entering the market. Joining me in moderation is my colleague and friend, David Wagman, a senior editor with PV Magazine USA. You can take this opportunity to say hi, David.
Hi, everybody. Thanks for joining us.
And alongside David, we have a trio of expert presenters here today. Daniel Chang, VP of Business Development with RETC, Greg Beardsworth, Senior Director of Product Management with Nextracker, and Vikash Venkataramana, Technical Director with Jinko Solar.
So before we hop into the presentation, we have a bit of housekeeping to take care of. If you've ever attended a PV Magazine webinar before, you may notice that this format looks just a little bit different because large format modules and PV's relationship with extreme weather are such diverse topics. We wanted to switch things up a little bit for this webinar. We want today to be just as much of a conversation as it is a presentation, which is why we have more presenters and moderators than usual, and why you can see all of our good-looking faces. This webinar will consist of 3 brief presentations with Q&A and discussions interspersed throughout. There will be more Q&A at the end, though you're free to submit questions at any time during the presentations. Due to time constraints, we may not have enough time to address every question, but we'll certainly give it a try. If you have any technical difficulties during the webinar, try exiting and refreshing your web page. There's also a help bar in the bottom left corner of your screen, and if problems persist, just shoot us a message and we will work to resolve it for you. In addition to myself and Tim, our colleague Beatriz is waiting in the wings to help out with any difficulties.
Okie doke. Now that the housekeeping is taken care of, let's switch our focus back to the topic at hand, reducing project risk for extreme weather. If you've been following any of PV Magazine's recent coverage, you know that extreme weather in all forms is something that project developers and owners are taking extremely seriously. Extreme weather, extremely seriously, of course. As these events, if unprepared for, can lead to massive financial losses. Almost every region in the United States is subject to some form of extreme weather. And speaking of extreme weather, David, I know you live in Colorado and can see massive amounts of snowfall in terms of feet over the course of just a few hours.
Yes, exactly. That's exactly right. And also hail. We have just in recent years had some massive hailstorms that passed through. There was one a couple of years ago that did around $1 billion worth of damage and knocked out a shopping center for the better part of a year. So it's quite an issue. And you, Tim, in North Carolina have issues related to high wind and hurricanes and those kinds of threats as well.
Yeah. I mean, I'm kind of new to the area, but historically, I know that hurricanes have been a huge problem in North Carolina, especially the closer you get to the coast. But, you know, we were kind of talking about how any region in the U.S. is subject to extreme weather. And I'm originally from Boston, and boy, we get all sorts of combinations up there. We get blizzards, we get hurricanes, we get our beloved nor'easters, which is kind of a mixture of a blizzard and a hurricane, and definitely not fun. I was actually born during a blizzard, so you really can't escape extreme weather anywhere in the country, and it's definitely an issue for large solar development. But if extreme weather is something that even the average resident of an area is cognizant of, it has to be a paramount concern for solar developers, owners, project operators, and their bottom line can depend on their preparedness and the hardware that they choose to resist the weather that they will be confronted with. With that in mind, I'm going to hand it over now to Daniel to hop into his presentation and shed some light about what this preparation and hardware consideration can look like. You ready, Daniel?
Yes, sir.
Cool. Floor is yours.
Can you guys hear me?
Yep.
Awesome. Thank you, everyone, for joining us here to discuss this really relevant topic of today. My name is Daniel Chang. I am the VP of Business Development here at Renewable Energy Test Center based in California. And we have spent a a great deal of effort actually addressing the changes that we're seeing in the industry, whether it be the larger modules, the changes of bill of materials, and also the deployment of these modules in more extreme weather condition regions. A little bit about RETC. RETC, Renewable Energy Test Center, has been around for a little over 11 years now, starting off as a resource for manufacturers to certify their products before entering the market. We have partnerships with all of the accredited laboratories. We are the laboratory of choice for many of them. And we actually branched out into doing bankability studies as we have seen a lot of new novel technologies enter the market. And as the modules actually changed, as the power increased and the demand for the higher wattage modules increased, there was also changes in the type of materials being used, the type of technology being used, and the best way to address that was to do testing that would go beyond the typical standards that are used to certify modules before they go to market. And by doing that, we were able to differentiate modules and also become a leader in understanding the effects of those changes. And very relevant to what we're discussing today, we have a combination of changes in the module itself, as well as the type of installations that they're going on to, as well as the regions that they're being focused on. And we recently branched out into energy storage testing as well, and have been doing some extensive battery testing for a lot of new manufacturers, and taking that same approach of creating a differentiating factor for a lot of new manufacturers that are coming to the market. So just as an aside, we have been monitoring the changes. Obviously, we are one of the first to receive a lot of these modules before they get to market, as they are tested, especially by the leading manufacturers before they go to market, right? And so one of the things that are happening is the increase in cell sizes. When the increase in cell size happens, so does the module size increase. And I think we all know this, but it's also driven by a lot of the combination of a demand for higher wattage modules, module cost pressures, and the ever increasing number of installations that are being made across the US and across the world, but in particular the US with the ITC. What I wanted to point out here is on the top left corner, it's an actual, that's a plot of the efficiency trends versus the type of time, of course. And as you can see, it kind of plateaus a little bit. There's a bit of plateau in the last decade, but we see a little bit of an uptick. But we understand that efficiencies have a theoretical maximum, and to address the demand for the higher wattage modules, the cell sizes have to change, right? They have to increase, and that is truly the way to get the best balance of cost and the higher appetite for the higher wattage modules. That, in combination with the second graph on the right, the decreasing costs of modules, has really made it so that large format modules, LFMs, are actually a result of all of this. And what we've seen is that, and what's very interesting is that, just a couple years ago, maybe 4 or 5 years ago, the wattage of 400 watts was even something that was unconceivable and very a feat of its own. And what we're seeing today is very amazing. Wattages that are reaching 600, 700 watts. Again, this is very good for the industry, again, but then we also need to make sure to understand that there are certain tests that need to be addressed when such larger modules are deployed. And we're seeing that the leading manufacturers are actually putting a lot of effort into making sure that they're proactive in testing before they bring these things to market. One of the things that we do, and I mentioned it earlier during our timeline of RETC's establishment, is that the thresher test, what we call, is a sequence of tests that are done to the module to address, again, higher standards beyond the typical UL and IEC standards. The flow chart on the right shows that we have actually a little bit of a sequence that's made to go beyond, and right, to go beyond. For example, thermal cycling is, for an IEC passing standard, is TC 200. We go to TC 600. Humidity freeze, damp heat, LETID, some of these standards just really almost bespoke to what's happening today in the industry. And one of the things that we've noticed, and is a big trend, is it just so happens that the leading manufacturers, the typical ones that you see as the top three, or the SMSL as they've coined it, have always been at the forefront of testing with this and making sure that even as almost in parallel with product development, they want to make sure that they can pass or at least do well on this, because what happens is, the results of this really determine the success of financing, for example, for a lot of these tax equity projects, and also the viability of the bill of materials that are being used. So the topic here again is about some extreme weather conditions, and one of those hot topics is hail. And hail is a very interesting phenomenon that's not really been addressed so much in the past, maybe 2-3 years ago. But I think with the proliferation of installations in Western Texas, where hail is a big topic, it has become a standard that really has to go beyond what is current today. And to address that, RETC launched the hail durability test, the HDT. By going through a series of different hail sizes that are detailed on the top right, it goes beyond the typical 25 millimeter size hail. And also we go beyond different points of the module. And we're not just necessarily looking for a breakage of glass or power loss for that matter. We're looking for the type of microcracks that result from that. And by characterizing the different types of microcracks that happen, and also classifying them within a color-coded kind of chart here, yellow, green, and red, we see that we can actually drop them in buckets: Class A, Class B, Class C, and Class D. And again, this is not just based on power loss or glass breakage, but really characterizing the type of microcracks that can happen and really actually expand and become a problem when a module is installed in the field and goes through the heat cycles of being in the sun, generating an electricity. So our flow here, of course, we do the hail impact for the various sizes. We do also some thermal cycling to emulate that the real life scenario of it being in the sun, and we also do some hotspot testing. By doing that, we actually are able to characterize this growth of some of these microcracks and then drop them into different whether they're uncritical, characterized as uncritical, critical, or very critical. And by quantifying that, we're actually able to come out with different classifications. This has helped the manufacturers again differentiate themselves, and also really help the insurance companies who have had a very hard time in the last couple of years in trying to insure a lot of these projects. Because again, a lot of the hail standard today, although it is being very looked under a microscope today by the official standards community, it is something that we need to do today just to address the demand of growth of projects today. The type of impacts that we do are based on the 5 different points here. A module edge of perimeter, center of the cell, edge of the cell, a ribbon of the cell, and an area free of cell. By doing this, we're actually able to emulate the type of impacts that could result from an actual installation. What's interesting from our results that we've seen is, again, the glass, right? So earlier I mentioned that we're not necessarily looking for glass breakage. We're looking for the type of microcracks in the HDT. However, to even go to qualify for the HDT and to really start that test, the glass shouldn't break, right? And what we've seen from our testing results is that a thicker glass, of course, many people could probably conclude this, but thicker glass has resulted in a higher resilience to breakage of glass. What we have also seen is an impact angle difference has significantly changed the type of breaks that could result from a hail impact. So what we see is the thicker glass, the 3.2 millimeter glass, has actually shown very favorable results for a larger size module, even up to 75 millimeters of impact. The 2 millimeter glass, which is very prevalent out there as a black bifacial glass on glass module, has also shown very good resilience to 55 and 65 millimeter hail, which is again larger than the 2-inch hail that averages out in Western Texas. So this is pretty good news. Again, glass breaking is the first step to at least address this. But again, I can't stress the importance of characterizing the cell cracking. And so I think this proves that, number one, thicker glass does help a lot in terms of withstanding the hailstones itself. But the tilt angle is very crucial, and some technologies with a hailstone capability, especially something that's done quickly when a hailstorm occurs, is very, very critical. And what we've seen is there's a lot of manufacturers. There's a couple manufacturers, especially the ones here that we're going to be talking right after me, that have addressed this, and we have actually seen very favorable results from that. So some pretty pictures here from a lot of these impacts. Again, the direct impact from a perpendicular angle is, of course, the worst case scenario, and we have seen breakages and significant breakages. This picture on the bottom right is actually a breakage of glass on glass module with a I think it's a 55 or 65 at a direct angle, but this is the back side of the module. So the hail actually went through the module itself, just to show that these hailstones are pretty scary, right? And so yeah, bottom line is, number one, modules are getting bigger. It's getting installed in more extreme environments such as hail-prone regions, and we as an industry need to react to this. And we have manufacturers that are actually taking it by the horn and really addressing it with new technology developments, bill of material focuses, and really a proactive way to address these things. So with that, I think I'm done. Yeah, thank you.
Excellent. Daniel, thanks so much. So hi, everybody. Greg Beardsworth here from Nextracker. Our headquarters in Fremont, California is actually just down the road from RETC's, and we really appreciate their partnership on this hail testing. Nextracker's reliability team was heavily engaged in that, and it's definitely a setup to a couple of the things that I'll be sharing with the group here. So before we get into hail specifically, well, first, a Nextracker overview. So for those who may not know, Nextracker has been the market share leader for single axis trackers for 5 years running. To date, we have about 50 gigawatts deployed in the ground and under contract. And we're part of Flex, a global leader in contract manufacturing, and that gives us an investment grade backing, which all of our customers and owners find valuable. We have offices all over the globe and a diversified supply chain, and in that sense, mitigate risk around trade disruptions, the pandemic, tariffs, and the like. So that's a little bit about us. Go to the next one here. Okay, so just a little bit about how we got here and kind of our industry firsts. So Nextracker really established the company and our technology by being the first to make an independent row self-powered tracker architecture, both reliable and affordable. This proved really attractive for both EPCs and owners by unlocking more energy yield and better utilizing available land, and also simplifying overall power plant O&M and site maintenance, ease of access through through a power plant over the long-term life. And we've been building on this foundation ever since. A lot of our focus since really establishing the technology category of self-powered independent row has been leveraging the communications and control capability that's native and built on board each of our tracker rows, and using that to create additional value for our customers. So things like streamlined commissioning and monitoring processes, true capture, that was a huge win for the company, our customers, and the industry as a whole. And that's all about yield enhancement for challenging sites with terrain and diffuse light conditions. And of course, relevant to this webinar especially, intelligent protection against severe weather. So firstly, wanted to touch on sort of the impact of large format panel as a trend on the tracker system. I think that's some helpful framework to ground this conversation. Nextracker has been preparing for the large format trend for about 2 years. We saw this coming, and there's been incremental growth of cell size and module size for a couple of technology cycles. And we've partnered close with PV providers and understand the technology, and really started the investment process, as I said, about 2 years ago, to be fully prepared and support large format across our whole product portfolio. And I'm proud to say we're in position to do exactly that now. Just highlighting a couple of the things. So of course, what the industry is excited about with large format is the increased power. And of course, that does mean more kilowatts per tracker, and indirectly faster tracker installation, because you have fewer large trackers to install for any given project as opposed to more smaller trackers. And there are efficiencies that come from that on the installation side. Of course, with that power, some of it is efficiency, as Daniel pointed to, but a bunch of it also is in the form of increased size. And not surprisingly, growth to the module form factor means increased wind loading and increased structural requirements. That's something, there are good and efficient ways to deal with that, and less good and less efficient ways. And we've invested a lot to find the appropriate way to do it. And then along with the size, of course, comes an increase in weight. And that really feeds into our dynamic analysis and also a set of structural enhancements. So again,
Greg,
go ahead.
With a question real quick here.
Yeah.
So the larger format of the modules and the greater weight of the modules, that doesn't do anything in terms of installation. It's still the same installation process. There's no additional labor needed per module.
Yeah, the installation process is pretty much identical. There are fewer panels to install on a given project. So, I really look to our EPC partners to be the expert on quantifying that. But on balance, I do believe it's a net improvement. Each module is a little bit heavier. I've not heard any, I don't believe the industry's hit sort of a break point where it's becoming prohibitive from a weight and labor perspective, although that is certainly a consideration that has to be factored in.
Thank you. I appreciate it.
How module interfaces with tracker, it's really no different on our side.
Thank you.
Yeah, thanks. Good, great question. So I'm going to keep moving ahead here. Really want to just emphasize the point on wind. Nextracker's done a number of white papers and webinars on sort of leading and advancing the standards on how wind design is done. As I think most know, just following code is not sufficient for a reliable tracker design. And really, the emphasis here is with large format panels, this is more important than ever. Bigger panel, bigger surface area, it highlights that it's just that much more important to get your wind engineering right. So without going into great detail, as we've touched on this pretty deeply in other forums, I just want to make the point that ensuring that the wind tunnel analysis is valid for the overall tracker dimensions when using large format modules is a must. And then the dynamic analysis is even more important and more critical. Since the beginning of trackers, dynamic, resonance type failures have been the leading cause of tracker damage. And we at Nextracker, through partnership with CPP, who we believe to be and have found to be the gold standard in pioneering this work, we analyze all the vibrational modes and include that or expand that analysis to include the size and weight of large format modules. So the takeaway for those here in the audience who are technology selectors is be very cautious, ask tough questions when selecting your structure. And we here at Nextracker would love to provide a solution for you. And we've gone through all this legwork and homework to be ready for these products. Whoops, I skipped ahead one. Perfect. So kind of connecting back here to Jinko and process, wanted to highlight that we work closely with Jinko and really think about testing the module and the tracker together as a system. So we have folks in the Nextracker team who are very close to Jinko's headquarters. So we coordinate with conference calls around the globe and physical co-located visits during load testing. And our process entails both doing fitment and installation testing to make sure we're not missing anything on just the basics of how the two components fit together and that they are installed quickly and easily. Of course, load testing, that photograph shows a whole bunch of actuators or pressure effectors pushing load on a panel attached to a Nextracker representative torque tube and mounting rail section. So this is a key part of the process for mutual compatibility between tracker and panel. And of course, out the other end of the whole process comes a compatibility letter co-signed by Jinko and Nextracker. And this is how we give our mutual customers confidence that the whole thing has been tested as a system. Pressure requirements or pressure limitations are clearly defined and the like. So go to the next one. There we go. Yeah, I want to highlight, some of the success factors. So as the latest iteration of cell and module sizes is going substantially above before. Good design of the panel itself really needs to consider the full range of wind pressures experienced on a project site, since that is the primary structural load. Things that need to be considered are frame design and attachment. How does that frame and module attach to the tracker? And of course, the stresses and deflections going on both within the module and the tracker structure. Important for folks to understand that between the most protected areas of a solar array and the most exposed, the wind pressures vary by a factor of 2 to 4x. And that really, the extreme pressures need to be considered. And of course, the bulk of the lower pressures do as well. And if this isn't done right, basically what can happen is the module, as it's bigger, may require more mechanical support to pass the load tests. And so a well-designed large format panel has very little impact to the overall cost of mounting those panels. But if these factors aren't considered well, and you see kind of this representative case study in the table there, what happens is it pushes a greater percentage of the modules on any given site require more reinforced, potentially longer mounting rails, thicker mounting rails, and really pushing a cost burden onto the balance of system. Indicative, this is kind of a representative example, but if the module is not designed properly to account for this, we could be talking on the ballpark of half a penny to maybe even a penny a watt of kind of downstream added cost to the owner in the form of more mounting rails and thicker and longer mounting rails and the like. So we commend Jinko for considering this very carefully up front, and we think they've done a nice job here with their upcoming category of large format panels. So now let's get to the fun stuff on severe weather. Interesting statistic you see in that pie chart there. Severe weather, the items in orange, sorry, it's a little bit small. While they're roughly a quarter of the quantity of damage events, they actually represent about 80% of the dollar value of damage events. So, you know, there's a clear financial reason why the emphasis here is on severe weather. On the Nextracker side, our NX Navigator user interface, making it very easy for power plant operators to both prepare for and respond to extreme weather events. That's really been our response, and it's been a technology we've been developing for a number of years. And we're tuning it in here to really have the best, most valuable features associated with response and prevention of severe weather. With our independent row, rapid responding tracker architecture, we can move the entire array or parts of the array very quickly into different positions, and that's enormously valuable. Specifically with large format panels, I want to highlight a couple, and we'll start with hail. You saw those images in the previous section with Daniel. Talked about both glass breakage, which is very obvious and easy to see, but also micro cracking, which is less easy to see, but you know, potentially even more impactful in terms of performance. So, you know, as the module format grows, the concerns around hail, wind, and snow potentially grow with it. Nextracker's hail stow mode, shown by, you know, a test comparing a 0-degree module angle with that hailstone impact and a 60-degree impact from that hailstone. We've seen through that testing in partnership with RETC a massive improvement in the survivability of that angle. So ballpark 81% growing to about 99.4% probability of surviving with a large hailstone, thanks to a rapid move into hail defense position strategy. And that's exactly what we're doing with NX Navigator. We also have intelligent wind stowing as part of that, and snow shedding as well. Tim, there was a question I saw you popped up.
Yeah, I just wanted to ask if your kind of hail or any sort of weather stow mode has been consistent across all type of modules, or if larger format or different styles of installations like 2-in portrait or the usage of bifacial, does that change stow mode at all, or is that 60-degree kind of optimal angle consistent across all types of installations and hardware?
Yeah, good question. Maximizing that or minimizing the angle of incidence there, or no, I guess technically that would be maximizing. Having the greatest sort of deflection and a glancing blow between the hailstone and the module, we believe is optimum pretty much regardless of technology. That said, we do have another round of testing being done with our RETC. And as we learn more, and if there's potentially evolutions to our thinking, we will certainly roll that in. And that's one of the benefits of the connectivity we have to our fleet of power plants. If we determine, you know, 2 years down the line that there's a better way of doing things, we can push firmware or software updates very easily to our fleet on behalf of our customers.
Awesome, thank you.
Absolutely. So I think we're going to the last one now. So I would be remiss if I didn't highlight True Capture. I mentioned before that this is, you know, a big step forward for Nextracker, our customers, and the industry. Yield enhancement solution associated with challenging terrain and diffuse light. We have over 15 gigawatts deployed and contracted. And the connection here with large format, it's less of a technology connection and more of just a general market trend. So as large format is contributing to solar economics getting better and better all over the place, you know, what we see is more and more of the market going into places with challenging terrain and variable weather. So really the use case for this technology and the value it brings is only going to grow, and it's completely consistent with and compatible with large format panels. So yeah, that rounds up everything that I was prepared remarks, and hope everybody found that useful, and we'll hand it off now to the Jinko team.
Before we hand it over, just if I could ask a question about testing, especially in the stow mode. if there are any recommendations in terms of increased testing to ensure that the panels stow as they're supposed to during a hail event, and if there are any requirements that you've seen coming from, say, insurance companies that require extra testing to make sure that that capability works when it's called for.
Yeah, great question. As part of our kind of standard operational guidelines for the asset owners who have Nextracker, there is a annual test of kind of all the functionalities around stowing and ensuring the system is working correctly. That's kind of done as a proof is in the pudding, show me kind of checkpoint, and of course the continuous connectivity to all the trackers and awareness of uptime of all the tracker rows on the site ensures that, you know, moment by moment the system is ready and available, and if there ever were to be an issue, that it could be corrected before severe weather comes to ensure all the trackers are ready to go. So that's how we handle that.
Good, great, thank you, thanks. All right, Vikash, sorry for the interruption. It's all yours. Thank you.
Thanks, Greg. Thanks, David. So yeah, I'll quickly, you know, give me a second. Perfect. Yeah, got my slide up. I'm Vikash. I'm the technical director here with Jinko, and I'm going to provide, you know, a module perspective. What you heard from Greg was, you know, a tracker perspective, and trackers is used widely in the utility space here in the US market. And I'm going to approach this from a module characteristics perspective and explain how we, you know, prepare for risk related to extreme weather. Quickly, before I get into the technical details, I'm going to give a brief overview about the company itself. A lot of you might be very familiar with Jinko. We are one of the largest module manufacturers around, and we have, you know, sales offices all across the world. And especially for the US, we make most of our product coming out of Malaysia, our factories in Penang, but we also have a factory in Jacksonville, Florida. And you know, we are in 109 countries, 15,000 employees. Our ingot capacity is about 20 gigawatts as of 2020. Wafer is about 20 gigawatts, cell 11 gigawatts, and module 30 gigawatts. So definitely doing this at scale. And you know, the US market is a very important market for us at Jinko. A little bit about the product itself and how it's evolved. As Daniel earlier mentioned, you know, the trend towards larger cells and changes in technology has been something that we've been seeing in Jinko for a few years now. We started with poly, then we went to mono, and then following from full cell, we moved to half cell designs, and then we did a differentiation in module technology called tiling ribbon. And since then, we've also, you know, periodically increased the sizes of the cells from going from 158 to, you know, now at 182. And I'm going to focus a little bit more on what our core products are right now in the US market. In the US right now, we sell what we call the G4 and the G5 series. The G4 series is a 163.75 millimeter cell. It's a 78 configuration module. So, you know, you're typically used to a 72 as a utility product, and this is a 78. And we also have the tiling ribbon technology here. Tiling ribbon is a proprietary technology developed by Jinko. And what this does is it reduces the spaces between cells and increases the module efficiency significantly. So we have this as one of our core products that we sell today and ship to the US market. We've been shipping this already in the US market and it's being deployed. The G5 is the other product that you will see, you know, deployed later this year. We've already manufacturing it, so it's the process of being shipped. The G5 uses a 182 millimeter cell, and essentially it gets you all the way up to 545 power. And you know, both products come in a monofacial and a bifacial version. The G5 uses the half cell format and 72 half cell. And the benefit with 72 being you have, you know, lower VOC that helps and adds more modules in a string. Brief overview of the products. I'm going to get a little bit deeper into, you know, what difference we have as being Jinko, right? You know, we like to reiterate here, and you know, Daniel mentioned a little bit about this. the Jinko modules all use 3.2 millimeter fully tempered glass. This has a huge advantage from a weight perspective, from the fact that you don't have two pieces of glass, and especially with bifacial, it's just a single glass with a transparent backsheet. So the weight significantly drops. It's also more durable, as Daniel highlighted through some of the tests that they've been doing at RETC, and it's industry proven. I mean, we've been using 3.2 for a while now, and thicker glass has been validated by this. We've got gigawatts of this out there, so it's not something new, which means less risk for you. And also want to reiterate here is that our glass is fully tempered, and there's a difference between fully tempered and heat strengthened and other variations of glass, and all of these affect the mechanical properties of the glass themselves. The other benefit that we have with our bifacial cells is we have full control from a quality perspective, from ingot all the way to module, because we make our own ingots, our own wafers, our cells, and also can control the quality across all of this, all the way to the module. We have greater control from a quality perspective, and especially in the US market, we try and make sure that majority of the product is all coming from Jinko, so say wafer, cell, module, essentially. Negligent LID, we've seen significant benefits as a result of change of doping. So the LIDs that we are seeing now are closer to less than 1% based on the LID standard testing. We have multiple bus bars. So I think the G4 has 9 and the G5 has 10 bus bars, and they are all cylindrical. Cylindrical allows more light to be reflected back, especially at low angles, which is a huge benefit. Also going to quickly highlight on our benefits with the transparent backsheet. In the US, majority, or primarily at least in the US market, we use the DuPont backsheet, which is it's PVF. It's highly UV resistant. Also in a bifacial application, it has the module itself is operating at a lower temperature. So if you multiply that with the thermal coefficient, you're going to end up getting a little bit more power. Also, low maintenance, hydrophobic surface, and so on. Also want to quickly highlight the frame. Jinko uses a 40 millimeter frame for in the utility space. So all our utility products right now use a 40 millimeter frame, and I can show you through testing and some of this data that we've collected. The durability is clearly connected to how durable your frame is, and that's a huge differentiation for us here in the US market. Okay, talking about extreme weather, I'm going to approach this from the perspective of extended reliability testing. So as you might all know, there's two standards a lot of the modules in the US are already certified to. One is the UL 61730, and the other one is the IEC 61215. So what extended reliability testing, and Daniel previously mentioned the thresher test does, is takes the standard and then says, let's just do more of this, right? So for example, TC200 is the minimum criteria, which basically is cycling from -40 to +85 degrees centigrade, which is pretty extreme temperatures in its own. And then what we then do is we do 3 cycles of this. So TC200 becomes TC600. And we again apply the same IEC pass-fail criteria, which is you should not have more than 5% degradation. And from our testing at third-party labs, we've seen less than 1-2%. And this is for our G4B product. All of this data is for G4B. And similarly, damp heat is another test where essentially you're at high temperatures with very high humidity, 85% humidity, and you're doing this for a significant period of time. The minimum criteria is damp heat 1000, which is 1000 hours, and we test all the way to damp heat 2000, which is 2 times the IEC criteria, and we are definitely less than the 5% degradation required, less than 2% actually. Another important sequence, which is pretty interesting, is the humidity-free sequence. Well, so what's done here is there's the mechanical load test followed by dynamical mechanical load, followed by thermal cycling, followed by humidity freeze, which is 85% humidity at 85 degrees to -40 degrees cycling. And in this particular situation as well, we do well below the 5% in terms of degradation. we're closer to 3, which is great, which is at H of 30, which is 3 times the humidity freeze that you would typically see for IEC. And finally, another test that we do here is the UV test. So essentially extended periods of time exposure to UV and understand how the module degrades. And as you can see, we've done 90 kilowatt hours and we're still like within 1%. I want to highlight all of this here because to kind of reposition ourselves from the concerns of extreme weather and extreme conditions, right? So all of these tests are pretty extreme conditions on their own. And as you can see, the module is prepared and can withstand these extreme conditions, which goes a huge way in saying that we are prepared for severe weather. Another important test that Daniel highlighted was the hail test. And the minimum criteria there is for IEC is 25 millimeter hail diameters with 23 meters per second velocity, and our modules, both the G4 and the G5, easily pass that. And what we've done is we've extended that from 25 to 35 to 45, and we are right now testing 55 and 65, and we really want to see how far we can take this. And Jinko having a 3.2 millimeter glass, fully tempered product, it's a clear advantage over dual glass competitors, especially on the bifacial side. So if you're really thinking about deploying modules in hail conditions, Jinko is probably the only module supplier here in the US that does a transparent backsheet with a 3.2 millimeter fully tempered glass product. And we're going to definitely stand out from all of our competitors out there from that perspective. As Nextracker and Greg mentioned, right, we also closely work with Nextracker right through our product release process. So even when we complete certification, the next step is for us to make sure we are firstly compatible with Nextracker, and then to what extent can we withstand snow loads and wind loads, right? So we do joint testing, and as Greg mentioned, we can provide a letter that basically says that we are certified to withstand certain loads. And we have these letters already for our G4 and G5 products. And this testing has already been completed. Finally, to summarize, before we get to the question section, is that, I want to reiterate here is that performance and extended reliability is a strong indicator for success in extreme weather, primarily because we're already pushing the modules here to, high temperatures, high humidity, and extreme environments. Not all large format modules perform similarly in all tests. People need to look closely at the module design, the materials, for example, the backsheets used, the glass used, the frames used, and the manufacturing processes in general, right? So we control every aspect of quality all the way from the ingot. So that's a huge differentiation. And Jinko large format modules, as you've just seen, perform really well in the extended reliability testing. And it's really important for customers, developers to look beyond just a module as a module. Understanding what glass was used, what frames are used, what backsheets are used is going to be critical for us to improve quality and maintain high standards in this industry. And it's good that we see this discussion and people asking more questions along those lines. And yeah, finally, the materials are what make modules. So it's very important to use high quality materials from reputed suppliers, and Jinko is committed to providing that quality both to our customers now and in the future as well. That's all I have from Jinko's side. I'll open the room for questions, and I'll let the moderators come in.
Awesome. Thank you so much, Vikash. And before we get into some of the submitted questions, I had one quick question if you wanted to hop back in. You kind of detailed the testing and importance of components in your modules, especially in terms of glass. I was wondering how much consideration goes into hail and weather resiliency on the frame side, especially if it's used in an Nextracker installation. The hail or the frame is going to be taking a brunt of that hail impact. So I just kind of wanted to get a vibe of what you guys are exploring on the frame side.
Sure, yeah. When it comes to frame, there's a couple of variables here, right? So I've highlighted the frame thickness being 40 millimeter frames. but it's not just the frame thickness. It's the amount of material you have in the frame. It's the design of the frame itself, for example, the cross-sectional profile, and also the wall thicknesses of the materials used in the frame, which all contribute to how well they perform in either mechanical load tests or in hail tests and so on and so forth. So we try and strike that perfect balance of where we can achieve this high performance with, say, the Nextracker system when you do mechanical load tests and hail tests, versus making sure that we are still cost competitive. So there's a lot of thought that goes into this, and at least from the way we see it, Jinko, we've invested more into our frame to ensure that we can differentiate from competitors. And that's why we have a thicker frame with better wall thicknesses and it's well designed to withstand extreme, say, mechanical load testing or hail conditions, if that makes sense.
Awesome. Yeah, that makes perfect sense. Thank you so much.
Sure.
We have,
You go ahead. And maybe ask Vikash to start on it, and then maybe Daniel and Greg also can get in. You all have mentioned international standards, IEC and UL standards. I'm wondering whether the international standards community is keeping up with kind of the rapid evolution of this issue related to weather-related impacts on solar, or if there's ongoing development or need for modified standards to address some of the issues you've been discussing. Vikash, what do you think? And Daniel and Greg also.
Yeah, sure. I'll start, and maybe Daniel and Greg can add more. So I think one of the great things that we did was we got to a unified standard. So we have now the UL 61730, which was previously the IEC 61730, and we now have a unified standard here. But the question that you're asking is this enough, especially for extreme weather, right? There is some effort to try and take the extended reliability testing and convert it into an IEC standard that, that could potentially be something that would be required for module suppliers here in the US. And that's being looked at very seriously considering the recent events and the concerns with extreme weather. But as a top module supplier, we already do that, and most of our utility customers ask us for extended reliability testing. And I think more effort in that area would make a huge difference. And also, like Daniel highlighted the hail durability program that RETC put across, right? And ensuring that in certain environments you do a lot more for hail. And these kind of efforts, I think there's some background work that's going to formalize a lot more into standards. And but as a module supplier, we welcome and we are prepared for these newer standards that are coming up.
Daniel, do you have a comment to make?
Yeah, absolutely. So the standards were again made based on technology that what we don't see today. I think that's what we're dealing with. The growth and the changes that we've seen so far have been extraordinary, right? The growth in power, I mentioned that in my deck. The growth in the type of installations that are being, the locations that they're being installed in, and the good news is from our insight that we hear and see that the standards community is listening, and they're making changes to the current standards as we speak, and they're chugging away, making sure that they can address this. But the reality is right now, the official standard of passing, taking hail, for example, a hail test at 5% of power loss is not enough, and it's actually creating a low curve for passing for a lot of these modules. And so, as Vikash mentioned, by participating in going above and beyond and testing in specific sequences that are more close to reality, close to what the modules will be actually be installed in, is very important. And that's one of the reasons why the HTT was developed, because we knew that the industry was moving very fast, and sometimes other things take slower. And so at the same time, these projects are not going to wait for us, right? And these projects need to be installed, and we're doing what we can to address that. So in short, yes, we see the standards community reacting to this, and so we thank them very much for that. So.
Great, thank you. And Greg, you have a quick comment? I know that we've got a lot of questions that we want to get to. Do you have a quick
I'll
comment?
add my perspective quickly here. So when we think about this from the overall system and tracker level perspective, I think there's with hail, I think there's an interesting analog with wind in that, the industry at the tracker design space has been operating in a sort of testing and science realm that isn't fully covered in code. I mentioned it that, if you follow just simple civil engineering code, which was really designed around buildings, you're going to have an under-designed tracker or a tracker that's not going to consider all the impacts. So we've really blazed our own trail here and pioneered how to do this dynamic wind and stuff that there really wasn't a precedent for. And in that category, it's still, there isn't a one code or standard to refer to on that. There's best practices of working with a firm who gets it and having peer-reviewed, reports which consider aeroelastic phenomena and the like. And I think, at the system level, hail may be similar. You saw that map, a probability of occurrence sort of heat map of the US. Right now, that's not kind of one of the design factors that a site has as a defining characteristic of like a hail recurrence interval or whatever. That may be an opportunity as we look ahead. And I mentioned also, different trackers have different characteristics in terms of how fast they could respond to an event. There's some testing around, tracking operations in the relevant UL and IEC standards for trackers, but they really weren't intended to cover that. So I think in the hail front, we're going to be in a similar place where we're at the system level, we're kind of blazing a trail there. And, the actual work happening to support projects is probably going to be out ahead of where the codes and standards are for a period of time. And we're excited to be a strong voice and participant in that.
Great. Thanks very much for all of that. Tim, I got some questions. I'll hand it over to you.
Yeah, the first one that I saw here that I thought was interesting is kind of directed again to you, Greg, and that is how you account for in analysis the wind loads on the perimeter of a project, especially at the end of a row, and how those can vary from what's seen across the row. So any considerations you have with the perimeter and end of rows as they regard to wind load?
Yeah, absolutely. That's a huge part of all of the wind tunnel work that we do with CPP. So the way those tests are set up involves measuring wind pressures throughout the spatial arrangement of an array, if you will, at different tracker angles and different wind approach angles. And so from all that, we do come up with a zoning that identifies, higher wind pressure zones from lower wind pressure zones. And that's all information that, Jinko, for example, when we're working with them on a module qualification, they get to see all that and understand what the system together has to be designed to.
Great. We had another one here. This is going to be for Vikesh. Kind of the difference between tempered glass and heat treated glass, and where the differences in resiliency come from there.
Sure, yeah, I think, fully tempered glass, the mechanical strength is different. And the way that works is, when they make glass, they typically heat it, I think, to 1200 degrees Fahrenheit. And then there's a quenching process. And depending, essentially, is a cooling process. And if you cool it rapidly, you see that compression and the pressure and the ability to withstand mechanical strength increase. But it becomes really difficult when you get to thinner and thinner glass to do that kind of quick quench process. And the real difference between fully tempered is its mechanical strength. So it has, a pressure of, I think, 10,000 psi that it can withstand, as opposed to 5,000 to 7,000 with non-tempered glass or heat strengthened glass. So that's where the differentiation comes, and it gets very difficult as you go to thinner glass to get it to be fully tempered. And that's where the challenge comes with thinner glass and not having the same mechanical strength as fully tempered glass at 3.2 millimeters.
Mm-hmm. Mm-hmm. Well, I see that we're kind of running out of time here, so I would like to thank you all for your presentations today. You know, I think this gave us all a very, very good perspective on kind of the relationship that PV has with extreme weather and how large format modules are throwing in new variables. And I would like to thank everybody in the audience for attending today. But before you go, we have a little bit of PV Magazine news to get to, as you can see right here. On this slide, we have a couple of featured articles. Hey, look, they're by me and David. If you want to scan the QR code, you can pull those right up. I know they're excellent because we wrote them. There's also a 10% off coupon code for a subscription to the print edition of our magazine. That is another QR code there, or you could use the code webinars 10. Speaking of webinars, we have a couple coming up, including one in Spanish, and I'm very, very rusty. My high school Spanish was a long time ago, so I'm not going to butcher that beautiful language by trying to read that. But then we also have Keep Cool and Distribute Stress, a recipe for improved performance, and that will be on Monday, the 26th of April. And I should have said it before, the Spanish webinar will be on Thursday, the 22nd of April, so just 2 days from now. And again, if you'd like to see more of our upcoming webinars, or you would like to rewatch any of our previous webinars, including this one will be out very, very soon, you can go to the webinar section of PV Magazine, or you could scan that QR code. So yeah, once again, thank you to all of our presenters and especially to the attendees for coming out to this webinar today. We really appreciate it.
Great, thanks everyone.
Thanks.